Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating the arbitrary constants from square root of 1 plus a square into log of z plus square root of z square minus 1 equal to x plus ay plus b. So here we are given an equation. We are asked to form a partial differential equation by eliminating the arbitrary constants a and b. Given square root of 1 plus a square into log of z plus square root of z square minus 1 equal to x plus ay plus b. Consider it as equation number 1. Now let's partially differentiate 1 with respect to x. Partially differentiating 1 with respect to x. Okay, so here we'll apply dou by dou x on both sides of the equation. We can directly partially differentiate 1 with respect to x, or you can just write dou by dou x on both sides of the equation. Okay, you can skip this step. Dou by dou x of square root of 1 plus a square into log of z plus square root of z square minus 1 equal to dou by dou x of x plus ay plus b. So here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, this gives us, here we can write this term as constant. Square root of 1 plus a square is constant into dou by dou x of log of z plus square root of z square minus 1 equal to partial derivative of x with respect to x, or just write one more step. It's right. This gives us square root of 1 plus a square into partial derivative of log of z plus square root of z square minus 1 is 1 by z plus square root of z square minus 1 into inner derivative, that is derivative of square root z plus square root of z square minus 1 equal to partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, right? This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into partial derivative of first term with respect to x plus partial derivative of second term under brackets with respect to x, okay, equal to 1, right? This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into partial derivative of z with respect to x, dou z by dou x plus partial derivative of square root of z square minus 1 is 1 by 2 root z square minus 1 into inner derivative, that is dou by dou x of z square minus 1 equal to 1, right? This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into, since we have a notation dou z by dou x equal to p, so let's replace it by p, since dou z by dou x equal to p. This gives us p plus 1 by 2 into square root of z square minus 1 into partial derivative of z square, that is first term with respect to x, minus partial derivative of second term. So you can skip this step. Actually you can skip both the steps and write directly. You can skip these two and write this step directly. P plus 1 by 2 into square root of z square minus 1 into partial derivative of z square with respect to x is 2z into dou z by dou x minus partial derivative of a constant with respect to x is 0 equal to 1. Again, since dou z by dou x equal to p, so we will replace this by p. This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into p plus 1 by 2 into square root of z square minus 1 into 2z, replace dou z by dou x p, you will get into p equal to 1. See here, you can write this term as 2zp by 2 into square root of z square minus 1, where 2 gets cancelled, right? You can cancel 2 here itself. Now you can take p common from these two terms. You will get square root of 1 plus a square into 1 by z plus square root of z square minus 1. Now take p common from these two terms. P into 1 plus z by square root of z square minus 1 equal to 1, right? Fine. You can write this as square root of 1 plus a square into 1 by z plus square root of z square minus 1 into, take this p here, we'll just bring this here, into, now simplify 1 plus z by square root of z square minus 1, you'll get square root of z square minus 1 plus z by square root of z square minus 1. Take the LCM of 1 plus z by square root of z square minus 1. Okay, this gives us p into square root of 1 plus a square into 1 by z plus square root of z square minus 1 into, we can write this fraction as z plus square root of z square minus 1 by square root of z square minus 1 equal to 1, where z plus square root of z square minus 1 gets cancelled. You will get p into square root of 1 plus a square by square root of z square minus 1 equal to 1, or square root of 1 plus a square by square root of z square minus 1 equal to 1 by p. We'll just take this p to RHS. Okay, consider as equation 2. Now partially differentiate this equation 1, right? Partially differentiate equation 1 with respect to y. Partially differentiating one with respect to y. Just apply dou by dou y on both sides of 1, or skip this step and do directly. Here 1 by a square is constant, so square root of 1 plus a square is constant. We can write it as square root of 1 plus a square into dou by dou y of log of z plus square root of z square minus 1. So you can skip the steps which are avoidable, okay? It's not necessary to write each and every step. Equal to dou by dou y of first term of RHS plus dou by dou y of second term of RHS plus dou by dou y of last term of RHS, right? So partial derivative of log of z plus square root of z square minus 1 is 1 by z plus square root of z square minus 1 into inner derivative, that is dou by dou y of z plus square root of z square minus 1 equal to, since we are partially differentiating with respect to y, so we'll treat x as constant here. So we'll get partial derivative of x with respect to y is 0 plus, here we'll treat a as constant, right, since it is an arbitrary constant, so we'll write it as a into dou by dou y of y plus partial derivative of a constant with respect to y is 0. Fine. Now this gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into partial derivative of first term plus partial derivative of second term. You can skip this step also and you can write directly equal to a into partial derivative of y with respect to y is 1. This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into partial derivative of z with respect to y, dou z by dou y plus partial derivative of square root of z square minus 1 is 1 by 2 into square root of z square minus 1 into partial derivative of inner derivative, that is z square minus 1. Okay, equal to a. This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into dou z by dou y. Since we have a notation dou z by dou y equal to q, so let's replace dou z by dou y by q. We'll get q plus 1 by 2 into square root of z square minus 1 into partial derivative of z square with respect to y minus partial derivative of 1 with respect to y equal to this a. Fine. This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into q plus 1 by 2 into square root of z square minus 1 into partial derivative of z square with respect to y is 2z into dou z by dou y minus partial derivative of a constant with respect to y is 0 equal to a. This gives us square root of 1 plus a square into 1 by z plus square root of z square minus 1 into q plus 1 by 2 into square root of z square minus 1 into 2z. Since we have a notation dou z by dou y equal to q, so let's replace it by q. You'll get 2zq equal to a. See, if you observe this, you can write this as 2zq by 2 into square root of z square minus 1, right, where 2 gets cancelled. Just cancel 2 here. In the next step, we'll take q from these two terms. Okay, q We'll take q common from these two terms. Fine. Now we'll write this as square root of 1 plus a square into, or I'll write one more step. Fine. And let me write one more step here. You can write this as 2zq by 2 into square root of z square minus 1 equal to a. Now cancel 2 and take q common. In the next step, you'll get square root of 1 plus a square into 1 by z plus square root of z square minus 1 into, just take q common, okay? You'll get q into 1 plus z by square root of z square minus 1 equal to a. Fine. This gives us square root of 1 plus a square into, we can write this fraction as 1 by z plus square root of z square minus 1 into q into, just simplify 1 plus z by square root of z square minus 1. Just take the LCM. Here z square, square root of z square minus 1 is LCM. In the numerator you will get 1 into square root of z square minus 1 is square root of z square minus 1 plus z. Clear. Now let's bring this here. We'll get q into square root of 1 plus a square into 1 by z plus square root of z square minus 1 into, we can write this fraction as z plus square root of z square minus 1 by square root of z square minus 1. Okay, or you can write the same step as okay, just by removing the brackets. Fine. Now you can cancel z plus square root of z square minus 1, and this gives us q into square root of 1 plus a square by square root of z square minus 1 equal to 1. So it's a, the RHS will have a not 1, I'm so sorry. It's a not 1, right? We'll get a. Now we can write this as square root of 1 plus a square by square root of z square minus 1 equal to a by q, considered as equation number 2. Okay. Now observe 1, equation 2, and it's equation 3, I'm so sorry, it's equation 3. By observing 1, 2, 3, we can say that by substituting 2 or 3 or 2 and 3 in 1, the arbitrary constants a, b, and here you're having a square, right, won't get eliminated. Okay, if you want you can check it out. See, from this you can write square root of 1 plus a square equal to a by q into, you can write this as square root of 1 plus a square equal to, or by a. Let's write constants in one side, right? And you can write this equation as square root of 1 plus a square equal to square root of z square minus 1 by b. Okay. Now observe these two equations. If you consider it as 3 and this is 2, by observing 1, 2 and 3, we can say that by substituting 2 or 3 or 2 and 3 in 1, the arbitrary constants won't get eliminated. Okay, because b remains the same here. Okay, b remains the same, and it is not possible to remove a also. You can check it later. So what we'll do is we'll observe 2 and 3. See, we have equation 2 and equation 3. In equation 2 you have square root of 1 plus a square by square root of z square minus 1 equal to 1 by p, and in equation 3 you have square root of 1 plus a square by square root of z square minus 1 equal to a by q, right? So from 2 and 3 we get, you can just equate these two, right? Since this term equal to 1 by b, the same term equal to a by q, the same term equal to 1 by b, a by q also. So we'll just equate them and we'll get 1 by p equal to a by q, or we can write this as a by q equal to 1 by p. Now take this q to RHS, you'll get a equal to q by p. Therefore a equal to q by p, right? Fine. Now substitute this a in any of these two equations, you will get the required partial differential equation. Okay, either you can substitute in 2 or in 3. Let's see in both the cases also. Let's see in both the cases. We'll substitute a equal to q by p in 2 and in 3 as well. You can just substitute in any of these two equations. Okay, it's not necessary to substitute in both the equations to find the required partial differential equation. So first I'll show for the equation 2. We have equation 2, square root of 1 plus a square by square root of z square minus 1 equal to 1 by p, or we can write this as square root of 1 by a square into 1 by z square minus 1 equal to 1 by p, or just bring this p here, we'll get, okay. Now substitute a equal to q by p, we'll get square root of 1 plus q by p whole square into p by square root of z square minus 1 equal to 1, which gives us square root of 1 plus q square by p square into p by square root of z square minus 1 equal to 1. Now take the LCM here, you'll get p square as your LCM, and in the numerator you'll get p square plus q square into p by square root of z square minus 1 equal to 1. We can split this square root as square root of p square plus q square by square root of p square into p by square root of z square minus 1 equal to 1. This gives us square root of p square plus q square by square root of p square is p into p by square root of z square minus 1 equal to 1. We can cancel p here. Now we have square root of p square plus q square by square root of z square minus 1 equal to 1, right? Or we can write this as square root of p square plus q square equal to square root of z square minus 1. Now by squaring on both sides, you'll get p square plus q square equal to z square minus 1. Okay, now bring this minus 1 to LHS, you will get p square plus q square plus 1 equal to z square, which is the required partial differential equation. See, it does not involve any arbitrary constants. Okay, so this is the required partial differential equation. Again, Now fine, this completes the problem. Now let's see using equation 3. We have to get the same equation. Let's see. We have equation 3, square root of 1 plus a square by square root of z square minus 1 equal to a by q, right? Now let's substitute a equal to q by p here. In order to substitute a, I'll write this equation as square root of 1 plus a square into 1 by square root of z square minus 1 equal to a into 1 by q for my convenience, since a equal to q by p. Now I'll substitute a here. Okay, right? We'll just replace a by q by p. Here you're having q, just cancel it. This gives us 1 plus q square by p square into 1 by square root of z square minus 1 equal to 1 by p, right? We can write this as square root of, take the LCM, p square is the LCM, in the numerator you will get p square, 1 into p square is p square plus q square. Fine, into 1 by square root of z square minus 1 equal to 1 by p. Now we can split the square root as square root of p square plus q square by square root of p square into 1 by square root of z square minus 1 equal to 1 by p. We can write the square root of p square as p, right, into 1 by square root of z square minus 1 equal to 1 by p. You can just cancel this p, then you will get square root of p square plus q square by square root of z square minus 1 equal to 1. Okay, or if you are confused to cancel p here, just take this p to RHS, then you will get p by p. There you can cancel it out easily. This gives us square root of p square plus q square equal to square root of z square minus 1. 1 into square root of z square minus 1 is z square minus 1. Okay, fine. Now by squaring on both sides, you'll get p square plus q square equal to z minus 1. It's z square, right? We'll get z square minus 1. Now bring this 1 to LHS, we'll get p square plus q square plus 1 equal to z square, which is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.